So I just wanted to add a little bit of exposure to Python to this video. I'm going to create a new Python file. And I'm going to call it InsertionSort.py. And I'm going to follow pretty much the same pseudocode that we had before. So to begin with, I'm going to create a list of items. We are going to call the list, this time we're going to call it data, and we're going to initialize it with some random numbers from 1 to 8. So I'm going to show you something interesting here. 2, 3, 4, 5, 6, 7, 8. So those are in order, which should be the best case for insertion sort. And I'm going to create a variable called length, and I'm going to initialize it to be the number of items in data using this Python function we saw before. But before I show you insertion sort, I'm just going to show you some interesting things about Python. I believe that there is a routine called there's a way to shuffle the data, and you don't need to worry about what this means, but you can import routines that have already been created in Python using an import statement. So there's actually a library full of other methods, and it's called random. And once I've imported it, I think I can set data equal to random dot. So you use dot to access the methods within the library. This routine called shuffle. What it does is you give it an array and it produces a randomized version of the array. So if I were to run this and then print data, if I were to run it, then what it would show me is an array with, oh, okay, so it printed out none. And the reason that it printed out none is because if I were to look up the documentation for this routine, it tells me that it shuffles data in place. So what this did before was it modified data and it returned nothing, and then I overwrote what it had just done to data with the value none. So hopefully it makes sense why it printed none down here to you. Let me try it now that I didn't overwrite data. So what happened is every single time I run this, I'll get a different random ordering of the data. Right? So if I run it again, it's just always a different random ordering of the data. Now sometimes we'd like to run it a whole bunch of times with the same sequence of data. So one thing that you can do is you can just copy here and you could paste it in. That might be the easiest. But also random.seed. And if you just give it a number, then it still produces an unpredictable array of data, but it always produces the same unpredictable one. So I guess you can predict it if you've run it in the past. And then every time I give it a different seed, it comes up with a different random permutation of the data. So that can be kind of useful for testing. I didn't want to go down too much of a sidetrack, but I did want to show kind of in here how we can obtain suitable random. It's not really random as we've seen because it always produces the same thing. So we're going to call this thing pseudo random input. Okay. And it would be interesting if you want to Google how your computer fakes random numbers. So now we've got a suitable input for an insertion sort algorithm. We can begin to actually write the insertion sort algorithm. And the way that it worked was we defined a variable called current, and we set that equal to the index 1, which is the index not of the beginning of data, but just one past it, right? Because the trivial first list was already sorted. And then we have a while loop, and the condition of our while loop, we're setting up a count-controlled loop that moves forward. So while current is less than length. What do we do? Inside of this, we're doing an event-controlled loop that scans backwards in order to find where the current item belongs in your currently sorted hand. Now it's event controlled, but it's it looks like a count controlled loop. So you would have index counting backwards, so you started off at current, and you decrement it, and you don't want it to reach 0. You want it to stop at 1. So what you do is you would say while index is greater than 0, and that would be a count controlled loop that moved backwards through the array. If some here you did stuff, and then you could set index equal to index. Remember, we're moving backwards, so we want to set it equal to index minus 1. So this is kind of the skeleton of your inner count controlled loop. And of course, I didn't complete the skeleton of the outer count controlled loop, because for that to work, I need to increment current each time. And as I think I've mentioned before, in Python, it likes you to use plus equals or minus equals as a shorthand for index equals index plus 1 or index equals index minus 1. This is, by convention, just considered clearer. So this is the skeleton of our code, except for that this inner loop, it's not actually a count-controlled loop. There's another thing that would cause us to bail out of that loop, and that is if we find the right place for the current item. So the way that we're controlling this loop is we're going to create a temporary variable called placeFound, and initially it's false because we haven't found a place for the current item. And we're going to keep scanning back as long as placeFound is false. And we don't usually explicitly check if it's equal to false. We just say if not placeFound, which is the logical operation. It returns the opposite of the value placeFound. So if placeFound is false, this whole thing is true. Right? So that's kind of our event-controlled loop. And in here, we need to do something which might cause placeFound to occur. So what we're actually doing, and this is the insertion sort algorithm, is you're scanning back, and as long as the item at index is greater than its predecessor, we swap them. So if data index is if it's less than its predecessor, then we're going to swap them, right? So we swap. So we set temp equal to data. Let's do data index. We set data index equal to data index minus 1, and we set data index minus 1 equal to temp. So that's our swap routine. I believe that is, yeah. So after swapping, the other thing that we have to do is if we don't need to swap it, then that means we found the right spot for the item. So else, this is the else for that if, we set placeFound equal to true. And this is correct, but it doesn't quite match our pseudocode because in our count-controlled loop here, we only decremented index if we swapped items. I don't think it's going to change the behavior of your program if you move this line of code up into that loop. So this part right here is swapping things, and this is decrementing the index. So this should exactly match the pseudocode that I had before. And if we feed it random inputs and cross our finger, at the end when I print data, it'll be sorted. All right? So I'm going to print sorted and data, and then beforehand I'm going to print input and what the data was on input, so we can see the difference. And if I run this algorithm, then we see down here at the bottom, oh, I just moved this out of the frame here. The input was kind of a random shuffled bit, and now the sorted part has all of them in order. Right? Now, because I randomly generated this shuffled bit, I can kind of test this. Just another. I'm done with the video now. I just want to give a couple of other little useful tidbits for Python before we go into the next topic, which is going to have to do with subprograms or procedures. I'm going to show you a few procedures that already exist in Python that you might find useful. So we saw here that I could hard code what the data is, and I could use a function called length that's built in to get the length of the data. So this is it's actually a subprogram. Random.seed is a function, it's a subprogram. It represents a bit of code that you can execute, and you don't have to type it again every time. You just say, I know how to start generating random numbers. I know how to shuffle data. Somebody else has written this code somewhere. I can probably go to the source somehow with this tool if I wanted to, but I don't need to. I can just call the method because somebody else has done it. So that's defining these subprograms. And a big part of learning a language isn't learning the language constructs. As we can see, they're pretty simple, but a big part of it is often learning the different set of procedures that exist. For example, in order to generate random numbers, instead of hard coding it like that, I could have said data equals random dot random. So I can generate a set of numbers that are within a range from 0 to 1. And I think I can generate a list of random. Let me see. I'm going to delete that from the video. So I'm going to delete everything after I showed the sorted data.